for our next example, we have to expand both of these out and bring the 4 over here. So when I square a binomial, I get a trinomial. A squared plus this times 2, 2a, plus 1 squared, which is 1, plus a times a squared, which is a, minus, because this is a minus, 2a plus 1, and then I'm going to bring the 4 over as a minus 4. And so now I'll combine like terms. I've got an a squared and an a squared, so I'll have a 2a squared, and then I have an a and a negative a, so I have no a's, and then I have a 1 and a 1, and I have a minus 4. So 1 plus 1 is 2 minus 4, which is a negative 2, which gives me 2a squared minus 2, which is equal to 0. Factoring out a 2, I get a squared minus 1, and that's equal to 0. And this is the difference of two perfect squares, so I have a 2 times an a plus a 1 and an a minus a 1. I recognize that as the difference of two perfect squares by very simply looking and seeing that I had a binomial with squares and a difference, and so I need the roots of each of them with a plus and with a minus, the conjugates. Remember, that's what that was called, conjugates. So we have an a plus 1 equals 0 or an a minus 1 equals 0, so we'll subtract the negative 1 and the negative 1 here, giving me that a is equal to a negative 1, or adding the 1 and the 1 there, giving me that a is equal to a positive 1 there. So we have either of those two choices. Either or is going to be my solution. All right, now moving on to my part G. My part G, what I'm going to have to do is to have this as a standard form equation first. So that'll be my first task, is to make it into standard form. So I'll need to bring the 2x over here to the other side. And then what I'm going to see is that this is actually not a quadratic equation, it's actually a cubic equation. And I can still solve these cubic equations just the same way as before, it's just that I'll have to factor out an x. So I'm going to have an x times 3x squared minus 7x minus 2. Equaling 0, and then I'll need to factor this trinomial as well. So now I have an x times a 3x and an x here for the factors of 3, and then a 2 and a 1 here for the factors of that. Now the only problem is I need to make a difference of 7. And I can't make a difference of 7, I can only make a sum of 7. So this one isn't going to factor, unfortunately, unless this one would be a plus. And unfortunately, it isn't a plus. So I think that this one actually needs to be a minus here, because I don't want to do the quadratic formula on this again, although I certainly could. So we're just going to change this one midstream, and then you'll see this become a positive, right? Which makes this become a positive, which now I've got the sum of a negative 7 instead the difference of a negative 7, which makes everything in the world work here. So we have an x minus 2 and a 3x minus 1. Now I'm going to set each of these factors equal to 0 that contain an x. So I have 1 and 2, and then 3 of these that contain an x, and therefore I'm going to have 1 root, and then this is going to give me another root. That 3x is equal to 1, and therefore x is equal to 1/3 as my second root, and then one more here, add the 2 here and here, so that x is equal to 2 as my third root. So we have 3 solutions to this one instead of just 2 solutions as we've seen in all the others, because this is a third degree polynomial equation, and third degree polynomial equations can have 3 possible solutions, up to 3 possible solutions. Not guaranteed there will be 3 of them, but there can be up to 3. I will continue problem number 2 in the next video.